So next problem, solve the Fredholm integral equation g of s is equal to 1 plus integral 0 to 1 s g of t dt by using successive approximation method. So given equation g of s is equal to 1 plus integral 0 to 1 s g of t dt, that is equation number 1. Here f of s is, so we know g of s is equal to f of s plus integral that is kernel into g of t dt. So f of s is nothing but 1, right? So let us take 0 order approximation b g naught of s, that is equal to f of s, that is equal to 1. So the first approximation is given by g1 of s is equal to 1 plus integral 0 to 1 s, replace g of t by first approximation, that is 0th order approximation, g naught of t dt. Substituting the value of g naught of t is 1, right? G naught of t is equal to f of t is equal to 1. So 1 plus integral 0 to 1 s dt. S is a constant, take it outside from the integration. So you will get 1 plus s integral 0 to 1 dt, that is equal to 1 plus s t lower limit 0 upper limit 1. So that is equal to 1 plus s. So g1 of s, first approximation is 1 plus s, that is equation number 2. The second approximation is given by g2 of s is equal to 1 plus integral 0 to 1 s, replace g naught by g1, right? g1 of t dt. So substituting the value of g1 of t from 2. So g1 of t is 1 plus t. So 1 plus s integral 0 to 1, 1 plus t dt. So separating into 2 integration. So 1 plus s integral 0 to 1 dt plus s integral 0 to 1 t dt. So integral dt is t. Integral t dt is t square by 2. So you will get 1 plus st lower limit 0 upper limit 1 plus s t square by 2 lower limit 0 upper limit 1. Substituting upper and lower limits, whenever you are substituting the lower limit, the value is 0, only we will get the value in the upper limit only, right? So 1 plus s by 2, that is equal to 1 plus s into taking s common, 1 plus 1 by 2. Keeping 1 plus 1 by 2 as it is, then only we can approximate the next term, easily conclude the next term, right? Next term, what will be the next term, what will be the third approximation, fourth approximation. That is why we are keeping 1 plus 1 by 2 as it is. If you are grouping that, then it is very difficult to identify the next approximation, right? So that is why, right, 1 plus 1 by 2. So therefore g2 of s is equal to 1 plus s into 1 plus 1 by 2, that is equation number 3. Now we are going to third approximation, g3 of s is equal to 1 plus integral 0 to 1 s into, we replace g1 by g2 of t dt. So 1 plus s integral 0 to 1, from 3 we are getting the value of g2 of t, 1 plus 1 by 2 t dt. So separating into 3 integrals, right? So 1 plus s integral 0 to 1 dt plus s into integral 0 to 1 t dt plus s by 2 integral 0 to 1 t dt. We know integral dt is t and integral t dt is t square by 2. Substituting, we will get 1 plus st lower limit 0 upper limit 1 plus st square by 2 lower limit 0 upper limit 1 plus s by 2 t square by 2 lower limit 0 upper limit 1. Substituting the lower and upper limit, we will get 1 plus s by 2 plus s by 4. So taking s common from second, third and fourth term. So 1 plus s into 1 plus 1 by 2 plus 1 by 4. See, the g2 of t is 1 plus s into 1 plus 1 by 2. So g3 is 1 plus s into 1 plus 1 by 2 plus 1 by 4, right? So you can easily come to a conclusion that what is the next approximation. That is why we are keeping the numbers as it is. So therefore g3 of s is equal to 1 plus s into 1 plus 1 by 2 plus 1 by 2 square. So automatically next is 1 plus 1 by 2 plus 1 by 2 square plus 1 by 2 cube, right? g4. So easily you can write the other approximations, that is equation number 4. So proceeding like this, we will get gn of s, right, which is equal to s into 1 plus 1 by 2 plus 1 by etc 1 by 2 power n. So that is, you can write it in a summation r is equal to 1 to n 1 by 2 power r minus 1, right? 1 plus 1 by 2 plus 1 by 2 square plus etc 1 by 2 power n minus 1 the term, right? gn means n minus 1, right? So up to you will get 1 plus etc plus last term is 1 by 2 power n minus 1. So summation we are writing in the notation 1 plus s into summation r is equal to 1 to n 1 by 2 power r minus 1. That is gn of s. Taking n tends to infinite on both sides, limit n tends to infinite, gn of s is equal to limit n tends to infinite 1 plus s into summation r is equal to 1 to n 1 by 2 power r minus 1. So taking g of s is equal to limit n tends to infinite gn of s, right? So g of s is equal to 1 plus limit, so 1 plus limit n tends to infinite s into summation r is equal to 1 to n 1 by 2 power r minus 1. So n in the summation becomes infinite, right? So 1 plus s summation n is equal to 1 to infinite 1 by 2 power n minus 1. Instead of r you put n, right? That's all. So if you are keeping r, then r is equal to 1 to infinite 1 by 2 power r minus 1. But we are taking n tends to infinite, that is why. So we are replacing r by n, right? Since summation n is equal to 1 to infinite 1 by 2 power n minus 1 is a geometric series with common ratio 1 by 2. That is the standard result we know, right? The end summation n is equal to 1 to infinite 1 by 2 power n minus 1 equal to 1 minus 1 by 1 by 2 minus 1. So we know if it is r is the common ratio of the geometric series summation n is equal to 1 to infinite 1 by r power n minus 1, then the summation is 1 minus 1 by r power minus 1. So instead of r you are having 2, right? That is 1 by 2 you are having, right? So 1 minus 1 by 2 power minus 1, right? 1 by 2 power n minus 1, right? That is why 1 by 2 is the common ratio. So 1 minus 1 by 2 power minus 1. So 1 minus 1 by 2, that is 1 by 2 power minus 1, that is equal to 2. So therefore g of s is equal to 1 plus 2s, which is the required solution of 1. Next problem, solve the Fredholm integral equation. G of s is equal to sin s plus integral 0 to pi by 2 sin s cos t g of t dt by using successive approximation method. So given equation g of s is equal to sin s plus integral 0 to pi by 2 sin s cos t g of t dt. That is equation number 1. Here f of s is first term, right? Sin s, right? Let us take the 0 approximation. G naught of s is f of s, right? That is equal to sin s. Now first approximation, that is, this is equation number 2. So g1 of s is equal to sin s plus integral 0 to pi by 2 sin s cos t, replace g of t by g naught of t dt, right? So substituting the value of g naught of t from 2, right? Sin s plus sin s integral 0 to pi by 2 cos t sin t dt. So that is equal to sin s plus sin s integral 0 to pi by 2. So multiplying with the 2 and divided by 2 with the integrand. So 2 sin t cos t by 2 dt. We know 2 sin a cos a is sin 2t, right? That is why we are going to use that formula. So sin s plus sin s by 2 integral 0 to pi by 2 sin 2t dt. So that is equal to sin s plus sin s by 2 sin 2t integral minus cos 2t by 2, right? So lower limit 0, upper limit pi by 2. So sin s minus sin s by 4, 2 into 2 4 in the denominator. Applying the upper limit cos 2 into pi by 2 cos pi minus cos 0. So sin s minus sin s by 4, cos pi is minus 1, cos 0 is 1, right? Minus 1 minus 1. So you will get minus 2 sin s minus sin s by 4 into minus 2, minus into minus plus, 2 and 4 get cancelled. So in denominator you will get 2 only plus sin s by 2. Therefore g1 of s is equal to, taking sin s common, so sin s into 1 plus 1 by 2. That is equation number 3. Now second approximation, g2 of s is equal to sin s plus integral 0 to pi by 2 sin s cos t g1 of t dt. So sin s plus sin s integral 0 to pi by 2 cos t sin t into 1 plus 1 by 2 dt, substituting the value of g1, right? So this is equal to sin s plus again we are multiplying 2 with numerator and 2 with denominator. 1 plus 1 by 2 is constant, take it outside from the integral. then it will become sin 2t inside the integral, right? So again integral of sin 2t is minus cos 2t by 2. That is why we are writing sin s plus sin s into 1 plus 1 by 2 into 1 by 2, right, minus cos 2t by 2, lower limit 0, upper limit pi by 2, right? So sin s plus sin s 1 into 1 plus 1 by 2. So applying the upper and lower limit, which is equal to 1 by 2 into 1 by 2 you will get, right? So sin s, taking sin s outside, now you will get 1 plus multiply with 1 by 2, 1, right, 1 into 1 by 2, 1 by 2, 1 by 2 into 1 by 2, 1 by 2 square. So sin s into 1 plus 1 by 2 plus 1 by 2 square. That is g2 of s is equal to sin s into 1 plus 1 by 2 plus 1 by 2 square. That is fourth one. Proceeding like this, easily you can conclude the general term gn of s is equal to, when you are getting g2 of s, sin s 1 plus 1 by 2 plus 1 by 2 square. If it is n, means 1 plus 1 by 2 plus etc etc 1 by 2 power n, right? That is what gn of s, right? That is equal to sin s summation r is equal to 1 to n, 1 by 2 power n, 1 by 2 power r, because r value is the summation, right? 1 by 2 power r. As taking n tends to infinite on both sides, limit n tends to infinite, gn of s is equal to limit n tends to infinite sin s summation r is equal to 1 to n, 1 by 2 power r, not n. So that is equal to sin s integral. Now you replace, right? Instead of r you put n, because n tends to infinite. So n is equal to 1 to infinite. That means r tends to infinite. N tends to infinite means r tends to infinite. Both are same. N is equal to 1 to infinite, 1 by 2 power n. So summation 1 by 2 power n is a geometric series with common ratio 1 by 2. So that summation is 1 minus common ratio, right? 1 minus r power minus 1. That is the general formula of geometric series. So 1 minus 1 by 2 power minus 1, that is equal to 2. So taking limit n tends to infinite, gn of s is equal to g of s, we will get the solution is g of s is equal to 2 sin s. So next method, if you are taking g of s is equal to sin s plus integral 0 to pi by 2 sin s cos t g of t dt, that is equal to equation number 1. Let us take the 0 approximation be g naught of 1, which is equal to g naught of s is equal to 1. That is equation number 2. The first approximation is g1 of s is equal to sin s plus integral 0 to pi by 2 sin s cos t g naught of t dt, right? So substituting g naught of t value, so you will get sin s plus sin s integral 0 to pi by 2 cos t dt. So sin s plus sin s into sin t lower limit 0 upper limit pi by 2, because integral cos t is sin t. So sin s plus sin s 2 sin s. So g1 of s is equal to 2 sin s. That is equation number 3. Second approximation, g2 of s is equal to sin s plus integral 0 to pi by 2 sin s cos t g1 of t dt. So sin s plus sin s integral 0 to pi by 2 cos t into 2 sin t. So sin s plus, so 2 sin t cos t is sin 2t, right? Sin 2t is minus cos 2t by 2, integral sin 2t is, right? So sin s plus sin s into minus cos 2t by 2, lower limit 0, upper limit pi by 2. So sin s plus sin s into, so substituting the upper limit, minus cos 2 into pi by 2 cos pi, minus cos pi minus cos 0, right? Minus cos pi is minus 1, right? So you will get minus 1 minus 1 minus of minus 2, right? So you will get sin s into 2 sin s into 2 by 2, right? So you will get sin s plus sin s, right? Therefore sin 2 sin s. So g2 of s is 2 sin s, fourth equation. Proceeding like this, we will get gn of s is, everything is 2 sin s, so you will get 2 sin s. So as n tends to infinite, limit n tends to infinite, gn of s is equal to limit n tends to infinite 2 sin s, that is equal to 2 sin s only, there is no n, right? So taking limit n tends to infinite, gn of s is equal to g of s, the solution is g of s is equal to 2 sin s. Thanks.